The transit of Mercury is a rare and fascinating astronomical event that occurs when the planet Mercury passes directly between the Earth and the Sun, appearing as a tiny black dot moving across the solar disk. This phenomenon provides scientists with valuable opportunities for research and offers an extraordinary spectacle for skywatchers. A planetary transit occurs when a planet crosses the line of sight between the Earth and the Sun. Due to their orbits, only the inner planets, Mercury and Venus, can transit the Sun as seen from Earth. Mercury, being the innermost planet, has a much higher frequency of transits compared to Venus. However, transits of Mercury are still relatively rare, occurring approximately 13 to 14 times per century. The rarity of these events is due to the inclination of Mercury's orbit, which is tilted about 7 degrees relative to the Earth's orbital plane, known as the ecliptic. As a result, Mercury usually passes above or below the Sun as viewed from Earth. A transit can only occur when Mercury is at inferior conjunction, when it is positioned between the Earth and the Sun, and is simultaneously aligned with the plane of the ecliptic. These alignments occur during specific intervals in May or November, with May transits happening less frequently, but offering a longer duration. The first recorded observation of a transit of Mercury was made by Pierre Gassendi on November 7, 1631. Using the predictive calculations of Johannes Kepler, Gassendi was able to witness the tiny silhouette of Mercury traversing the Sun's surface. This observation was significant in the history of astronomy as it validated Kepler's laws of planetary motion and demonstrated the practicality of using transits for celestial measurements. Subsequent observations of Mercury's transits have contributed to various scientific advancements. During the 18th and 19th centuries, astronomers used transits of both Mercury and Venus to calculate the astronomical unit, AU, the average distance between the Earth and the Sun. By carefully timing the transits from different locations on Earth, scientists could apply the principles of parallax to estimate this fundamental astronomical constant. A transit of Mercury unfolds in distinct phases. The first phase, known as first contact, occurs when the planet's silhouette first touches the edge of the Sun's disk. This is followed by second contact, when Mercury is entirely within the solar disk. The transit progresses as Mercury moves across the Sun, creating the visual effect of a small dark circle traveling against the bright solar background. The event concludes with third contact, when Mercury's edge touches the opposite limb of the Sun, and finally fourth contact, when it completely exits the solar disk. Mercury appears remarkably small during a transit because of its vast distance from Earth relative to its physical size. With an angular diameter of approximately 12 arcseconds, Mercury's tiny disk is barely noticeable without magnification. This underscores the importance of using telescopes equipped with solar filters to safely observe the event. Mercury's rapid orbit around the Sun, taking just 88 Earth days to complete, plays a crucial role in determining the timing of its transits. The planet's orbital speed and proximity to the Sun mean that its transits are relatively swift, typically lasting between 5 and 7 hours. The exact duration depends on factors such as the specific alignment and the observer's location on Earth. May transits occur when Mercury is near aphelion, the farthest point in its orbit from the Sun, resulting in a slightly smaller angular diameter and a longer path across the solar disk. Conversely, November transits take place near perihelion, where Mercury's orbit brings it closest to the Sun, resulting in a shorter transit path. Transits of Mercury provide unique opportunities for scientific study and have been used in various ways to advance our understanding of the cosmos. Some of the key applications include measuring the Sun-Earth distance. Historically, transits were instrumental in calculating the astronomical unit. Although modern techniques such as radar and spacecraft telemetry have surpassed this method in accuracy, the historical context remains important. During a transit, scientists can study Mercury's tenuous exosphere by observing its interaction with sunlight. This exosphere, composed of atoms such as hydrogen, helium, and sodium, is created by solar wind and micrometeorite impacts on Mercury's surface. Spectroscopic observations during a transit provide insights into its composition and behavior. The precise timing and observation of Mercury's position during transits contribute to testing the predictions of general relativity, particularly concerning the precession of Mercury's orbit. Mercury transits provide a unique opportunity to study the Sun itself. The planet's silhouette can help calibrate instruments used to observe the solar disk and refine models of solar limb darkening, the gradual decrease in brightness from the center to the edge of the Sun. Observing a transit of Mercury requires proper planning and equipment due to the Sun's brightness and Mercury's small size. Directly observing the Sun without adequate protection can cause serious eye damage, making solar filters essential for safe viewing. Specialized solar telescopes, binoculars with solar filters, or projection methods are commonly used for transit observations. The best locations for observing a transit depend on the geographical visibility of the event. Transits can be partially or fully visible from different parts of the world, and weather conditions play a significant role in determining the success of observations. Astronomical organizations and observatories often organize public viewing events to provide safe and guided experiences. The Transit of Mercury is not only a scientific event, but also a cultural and educational phenomenon. It inspires curiosity and wonder about the universe, offering an opportunity to engage the public in astronomy. Events like these bring communities together, foster interest in science, and encourage discussions about our place in the cosmos. For educators, the transit serves as a practical demonstration of orbital mechanics and the scale of the solar system. It provides a tangible way to illustrate concepts such as planetary motion, alignment, and the nature of astronomical observations. The rarity of Mercury's transits makes them highly anticipated events for astronomers and enthusiasts. The most recent transit occurred on November 11, 2019, and the next will take place on November 13, 2032. After that, a series of transits will occur at intervals ranging from 7 to 13 years, following a predictable pattern based on Mercury's orbital dynamics. The long intervals between transits make each occurrence a unique opportunity to witness a celestial event that connects observers across the globe. Advances in technology, including high-resolution imaging and live streaming, have made it possible for more people than ever to experience the spectacle, even if local weather conditions are unfavorable. The transit of Mercury across the Sun is a remarkable astronomical event that combines scientific significance with visual beauty. Its occurrence reminds us of the intricate dance of celestial bodies and the importance of precise observation in understanding the universe. Whether viewed through a telescope or as part of a global outreach program, the transit of Mercury offers a chance to appreciate the grandeur and complexity of our solar system.